Welcome to lesson 10.7, 10.8, arcs and angles with chords, secants, and tangents. Now, out of all the circle lessons we have done, I would say this one has a little bit more applications, especially those who are in the surveying field. A lot of surveyors use this type of math, especially when they have to go around circles and objects and they need to find angles and also arc angle measures. A lot of different applications, but we're going to keep it as basic as possible so you get an understanding of what's going on. I really do wish we could do a classroom experiments with this because this one has a lot of interesting things going on with it. But let's go to it. There's going to be 3 different formulas you're going to need to know in order to solve these problems that you're going to do in this lesson. So let's begin with this first picture. In this picture we have a circle with a chord and a tangent. Now, when you form a tangent and a chord right here on the edge of the circle, you're going to have 2 angles. Alright, you got this 70-degree angle, and of course you have an angle right here. And what you're going to have to determine on these pictures are what are the angle measures or what are the arc measures. And there is a simple formula that you'll use. If you take the angle that is formed by the chord and the tangent, so this would be the angle, and you multiply it by 2, you will get the measure of the arc. So the arc is equal to the angle times 2. Alright, so if this is 70 degrees, then this arc from here to here would be 140 degrees. Now you can go backwards on this, of course, because sometimes they'll give you the arc and you have to find the angle. So that would be the arc divided by 2 is equal to the angle. So if our arc is 140 divided by 2, you get the angle 70 degrees. Now there's some more complex stuff that you'll see in your problem set in just a little bit, and which they might ask you, if they give you this angle, what is this angle here or this arc here? Well, you can simply find this arc because we know that all circles are 360. So if you just take 360, subtract 140, you get 220 degrees. So really simple as long as you know what that arc is. And then they might ask you what that angle is. Well, the arc divided by 2 is equal to the angle. So that would be 110 degrees. Yeah, but I'm sure a lot of you noticed something that's introduced to geometry very early. We have our straight line, a linear pair, supplementary angles. So if you make that straight line, these 2 will add up to 180 every single time. So 110 plus 70, of course, gives you 180. So I could have found that 110 by just simply saying 180 minus 70 to give you the 110. Alright, so that is the first type that you're going to look at. Now, our second formula and third, I call these the coffee problems or coffee cup problems. What we're looking at is 2 chords that are intersecting each other, and they are forming these little arcs. Okay, so we have an arc, and we have these corresponding kind of angles with the arcs. Now these are vertical, so you know whatever this is the same. So what we got to do is, how can we find the measure of those angles when we are simply given the arcs of the 2 chords on the outside of the circle? So here's where I come up with the coffee cup problem. Alright, so we need coffee to get our edge. So I got my Star Wars coffee cup here, And when we fix our coffee in the morning, of course, we pour it in the cup. So we are adding that edge to ourselves. We're adding that coffee to the cup. Now you're going to see what I'm talking about in just a minute of why I'm using this as an analogy. So we're adding the cup or coffee to the cup. Here's our circle. Here's our circle. So the coffee is inside of the cup. So since we added the coffee in, we're going to add the arcs. So here is the formula. Arc plus arc divided by 2 is going to give you that corresponding angle on the inside. Alright, so here I have 40 degrees for that arc, 50 degrees for this arc, divided by 2. 40 plus 50, of course, is 90. 90 divided by 2 is 45 degrees. So these two angles are 45. And we can do a quick check. I actually measured the arcs beforehand, so we're going to see if this gives us our 45 degrees. And there we have it, 45. And that's how you do this type of problem where you have to find the angle on the inside. Now, we are going to find the arc, but I will show you that in the example in just a minute, that you'll have to do it on your assignment. Now, let's look at our third and final formula. Now, this time, look where our angle is. We have 2 secants that is forming an angle outside of the circle. So here we have our coffee cup, and I don't know, we do something and we're a little clumsy and we spill it. Well, what's going to happen to the coffee? It's going to pour out onto the table. Alright, so our edge, our angle, whatever, is going to go outside of the cup. So we have less coffee in our cup, meaning we are subtracting. So in this case right here, it's just like the previous formula, except our angles on the outside, and instead of adding the arcs, you're going to subtract the arcs. So this would be arc minus arc divided by 2 is going to give you that angle on the outside. So we'll just call that x. So this would be 80 minus 34 divided by 2 equals 2x. 80 minus 34, that's 46 divided by 2, and that would give you 23 degrees. And if you, of course, take a protractor, measure it, you should get around 23 degrees. And that is the 3 formulas we're going to use. I know a lot of y'all were confused about the forms, Microsoft Forms I was doing, and they were not corresponding with the video and the numbers, because number 1 is the video. So question number 2 is the first problem in the video. So y'all wouldn't get confused. I went on and put number 2 as your very first problem that you're going to work. Alright, when you do number 2, you are going to look for angle number 1. Now, it will have 1 and 2 in the problem, but I just need you to help find angle 1. You got 2 ways of working this problem. Alright, so I'm going to show you both ways, so you pick the way that you like the best and take it from there. You'll get the same answer regardless. Alright, so one way to get angle number 1 is noting that the entire circle is 360 degrees. So we take away the 112 and you get 248. So that is the measure of this arc here. Now, using our formula, the arc divided by 2 is going to give you the angle. So the arc is 248 divided by 2, and you get 124. And that would be angle number 1. The second way you could have done this problem is you take the arc divided by 2 gives you the angle. So 112 divided by 2 gives you 56 degrees. So this is 56. And since we have a straight line, linear pair, supplementary, if this is 180 and that is 56, 180 minus 56 is 124. So you have two ways of working that problem. Number 3, we need to find arc number 2. Two ways of doing this problem. Probably the easiest way, since we know the angle times 2 is equal to the arc. Here's the angle, which is 120, multiply it by 2, and we get an arc of 240 degrees. So it's 240 from here to here. It's 360 all the way around. So 360 minus 240 gives you 120 degrees. The other way you could have done this is a linear pair. If that's 120, then this would have to be 60, because 60 and 120 is 180. And if you take the angle times 2, you get the arc. And that's for number 3. Number 4. Now, here comes the coffee problem inside of the cup. So the angle is on the inside, and we want to find that measure. So if you look at your formula, it says arc plus arc divided by 2 is equal to the angle. So this is 30 plus 70 divided by 2. 30 plus 70 is 100. 100 divided by 2 is 50 degrees. So angle 1 is 50 degrees. I take my protractor, let's put it on 50 degrees, lay it down, and you see it matches up 50 degrees. So it works. That's number 4, very simple. Now number 5, a little bit more complex. It uses a little bit of algebra, but no big deal. So the angles on the inside, we're going to add arc plus arc divided by 2 equals to the angle. But this time, we don't know what this is. So let's assign an x. So 1 would be, or x would be the first arc. 35 is the second arc. Divided by 2, and that's going to give us the angle. See, this time, the angle is given on the inside, which is 36. Now remember, when you are dividing by a number, a algebraic expression by a number, just simply take that 2, multiply it over here to the other side. So that would give you x plus 35 equals to 2 times 36, which is 72. And then simply subtract 35 from both sides, and x is 37. And that would be for arc number 1. All right, moving along. Number 6. Number 6, we have the angle on the outside. Since the angle is on the outside, we are going to have to subtract. See, the coffee has spilled out of the cup, so we're subtracting that angle, that coffee. So this would be arc minus arc divided by 2 equals to the angle. So we have 74 minus 20 divided by 2, and that's angle 1, so we can assign an x to it. So we'll make that x. 74 minus 20 is 54, and 54 divided by 2 is 27. So angle 1 is 27 degrees. Let's look at a little bit more complex one of the angle on the outside. Now, since the angle's on the outside, we still use the same formula. Arc minus arc divided by 2 equals to the angle, but we've got a problem here. I've got this arc, 126, but I don't have this arc here, so I need this arc in order to get that angle. Well, let's see what we got in our picture. Oh, I have 110 from here to here. That's 126, and this is 100. If I take 360 and subtract the 110, 126, and 100, that should give us this arc here. So when I subtract all three of numbers from 360, I get 24 degrees. So the measure of this arc is 24 degrees. Now I have enough information. Arc minus arc divided by 2 gives you the angle. So 126 minus 24 divided by 2. That's 102 divided by 2. And 102 divided by 2 is 51 degrees. And that would be the measure for angle number 2. So that's what you'll be looking for when you do number 7. Number 8. Alright, this is going back to the first formula, except now we're going to use a little bit of algebra with it. Alright, let's see what we have here. We have our angle and our corresponding arc. So remember, 2 times the angle, or angle times 2, is equal to the arc. So if I take 2 times this angle, which is 4x minus 1, it will equal to the 6x plus 46. Please don't forget to put parentheses around the angle here, okay, because when you distribute, you got to distribute everything, even that 1 over here on the right side. So let's distribute, and I get 8x minus 2 equals to 6x plus 46. Subtract 6x. 2x minus 2 is 46. 2x is 48. And x equals 24. I'm not going to ask for an angle measure on this. Just simply find x. And there you have it. Finally, number 9. This will be your last problem. This problem looks really simple, but is complex on the way you have to think about how to solve for x. Alright, because I only have one number. That's it. So now I got to start thinking what other variables or numbers I could use to help me figure out what in the world x is. Because this is arc minus arc divided by 2 equals to the angle. And all I have is this 68 degrees, and I have this x right here. But what about this arc? How am I going to find that? Alright, how many degrees are in a circle? Yes, 360. From here to here is x. From here to here is 360. Well, if this is x and the whole thing is 360, then from here to here is going to be 360 minus x. So if I take 360 minus x, I get this arc. Now look what I have. I have arc, arc, angle. Now I can solve for x. So arc minus arc divided by 2 is equal to the angle. 2 times 68 is 136. Negative x minus x is negative 2x. Now this problem's starting to look a little funny because we have a negative variable. But watch what's going to happen. When I take my 360 and subtract it on the other side, I get negative 224. See, we all know that two negatives make a positive, so the negatives are going to go away anyway. So when I take 224 divided by 2, I get 112. And that's all I'm asking for on that. Okay, take your time, pause the video anytime, look back at each problem and watch exactly how I do this, and then you should have no trouble finding the correct answers. Alright, see y'all later.